again and install. Now, after looking this topic, we're just moving to quickly look on different type of boosting algorithms. Boosting algorithms. So there are several. One of them is Adaboost. Next is gradient boost, and last one is XgBoost or extreme gradient boost. So let's look firstly upon Adaboost. So Adaboost uses sequence of weak learners called stumps. So stumps looks like this. It is nothing but a decision tree with only 2 leaf nodes. Decision tree with only 2 leaf nodes. Right? These are all weak learners. Weak learners, and they are called what? Stumps. So to understand this scenario, we must first understand that how it's working with the help of a practical example. Apart from that, let's understand that what are the benefits of using Adaboost and how it's helpful. Okay. So first few points, key points you might remember while using Adaboost are, first of all, we use weak classifiers, basically called stumps. Second thing is, and that is most important, only binary classification supported. Right. And third thing is that uh, every stump predict only 2 things, either +1 or -1 for the first or the second class value. Okay, these are the key points, and above that, this is the most important point you can say. It only supports binary classification. Right. There is one mathematical formula associated with this, that is regarding misclassification rate. That is nothing but error equals to correct minus n divided by n. And that you should keep in mind while learning Adaboost. Next, we will look on something about flowchart of Adaboost. Let's look at flowchart of Adaboost. First step, we have to train in subset which is selected randomly. The next step, what we'll do, it will follow an iterative process. Next thing is that if something is misclassified, means it is wrong, then it will be associated high negative weight. High negative weight. Okay. Next is that according to these weights, it's again train model, and finally this will repeat. So this is the basic process of Adaboost algorithm. You can see it with the help of flowchart. Next, we'll be looking at how it's actually mm, different from something known as gradient boosting. But before that, let's look at what is gradient boosting. So we have already discussed that in case of boosting, we have done Adaboost. Now we'll be working on gradient boost, and next we'll be looking at extreme gradient boosting. So let's look and see what is gradient boosting. So the first thing about this, that it trains many models sequentially. And uh, it tries to minimize the loss. And which method it uses? It uses gradient descent method. So if you are not familiar with gradient descent, it is a curve. Here is a graph of gradient descent. It looks like this. This is a graph between error and maybe some other parameters like learning rate or a number of estimator. And here in the gradient descent, we tend to find the minimum error. Okay, so this is the gradient descent method. Now, in the prediction of any output, mathematically, if we see if there is some output, in the case of let's say linear regression, and it predicts ax plus b, there is some error term. There is some error term. Error term. And in the gradient boosting, we pay much attention to this thing. And we try to minimize it. Okay, so basic idea is that let's say you have a model and it predicts an output, okay, and it produces some error u. Now this is an error. Now in order to minimize it, it will create another model m2. This will give us some output, and it will say let's say it has even error, and let's say it has e2 error. So what will it do? It will create another model m3, and it will go up till this error is minimized. So practically, if we try to understand this model or this algorithm, we consider, let's say you are making a pot. This example we have already considered, but let's revise it and revisit. In first time you tried and you build something like this pot. Okay, it doesn't look even like a pot. Next time, what you will do? You will try to reshape it and try to get it in some better shape, but it's not well yet. So next time, what you will do? You will again revise your learning and try to make a perfect looking pot. Even though it's not perfect, but this is the process of gradient boosting. In each and every step, you will try to minimize the error. Minimize the error. Okay, so this is the basic approach about gradient boosting mechanism. Okay, if we look these terms technically, let's say you have output y1 and we have output at y2. This is basically actual and predicted. You will get some residual, basically r1. Now based on that, we'll do again some model training and we'll get residual r2, basically on some other model. Right? That's what we are talking about, this thing. And on performing a series of things, you'll get different uh, residuals, and based on residual you will try to tune your output. To explain this, let's consider an example. Let's say you have a data set and you have, say, age as an input, and based on this age and let's say height, you are giving BMI. Okay, let's say for the age of 20, you have a height of 160 and your BMI is 22.4. Let's consider a whole number for now, 22. Okay, fine. Now let's, for the age of 21, your height is 170 and your BMI is 23. And for the age of 23, your height is 175 and the BMI is 24. Now, let's say this is our input feature F1, this is input feature F2, and this is your output feature you want to predict. So now how I'll try and run gradient boosting practically. This is, let's say, your, what we call it, it's your output, actual output. Now what we will have in first time, we'll try to take and assign average of each as a predicted output y1. So it will be 23 obviously. Now we'll calculate residual one, basically a difference between these. So let's say this is -1, this is 0, and this is 1. Now in the second time, what will we have? We have got our residual R1. So next time we'll train this feature with this residual and get some residual R2. Let's say we get -0.11, 0.2, and 1. So this time we got this residual based on training of this feature 1 and feature 2 and this R1. This process will go on until this R1, R2, and up to Rn, it diminishes. Or either we stop it intentionally, right? So what is the new value after this updation? What is the new value after updation? It was nothing but the base value plus alpha into residual 1 plus alpha into residual 2 and so on. So there, if you notice it very carefully, this thing we were looking, okay, there is a formula for new, wait, in the W old equals to W, this is W new, you might have seen it in neural network or even linear regression, plus alpha times WE by DW. So this is you are used to do, and we were doing, we were adding some residual. This was the updation formula. Now, in case of linear regression, we have something called as L1 and L2 regularization. So now, if you look this formula carefully, we are technically adding a regularization term out here. Notice, if you consider linear regression, and that what we were doing, we were having some error calculation formula, and at the last we were using some alpha square or something like that, or maybe mod of p and p. These were what? Regularization terms. So, and these were very small, but what they were doing, they were avoiding overfitting. So these are the same things with this formula out here. What we are doing, as soon as we increasing this term, this will try to regularize the model. Okay, so this is the basic intuition of gradient boosting. Next, we'll see if instance will I think I have explained you the algorithm, so no need to write them in point. Next we can see something called as extreme gradient boosting. XgBoost. So in full form, it is what is called extreme gradient boosting. Okay, so some key features of it, like it is a tree based model. Okay, and it avoid overfitting and used in competitions also. Right. So there is basically a dedicated library for this. What features does it provide? It has parallelization feature. Parallelization feature. It has uh, continued training feature. It has it is using gradient boosting basically as base and using gradient descent. Stochastic gradient descent as for the thing, and we are using regularization L1 and L2 both for this XgBoost. Okay, I think this is pretty much about the XgBoost. There are some parameters associated with this. Parameters. There are three parameters associated with. One is general parameters. Then some are task parameters, and some are booster parameters. So while we will be doing the practical implementation of this algorithm, we will be looking at those things. There's I think no need to discuss them in story because you won't get very much intuition about things. Next, we'll be looking at something called as cross validation or basically model evaluation. So to evaluate models, there is some called model evaluation. So basically, we'll be trying to evaluate our model based on some validation techniques such as cross validation. We'll be using something like confusion metrics for this confusion metrics. We may also use accuracy, AUC, ROC, and so on. So next, we'll be looking at this kind of thing. That's it for the today's video. Thank you.